Hi guys, so welcome to my channel, and all of you know that my name is Ashwani Kumar, and in this video we are going to see the UGC NET 5th November 2020 few memory based questions that we are going to see here. So whatever the questions we are going to see in this present session, so apart from these questions, if you remember or else if you know any questions, then please put your remembered questions in the comment section of this video guys, okay, so that I will come up with the next video, so to the solutions of that one. Fine. And myself, I'm Ashwani Kumar guys, and I am the Unacademy educator for the electronic science as well as a general paper 1. So from November 9th onwards, the UGC NET paper 1 and the electronic science, both these two are going to start for the fresh batch. So the complete course is going to start for the general paper 1 from November 9th onwards, and for the electronic science November 10th onwards. Okay, so the interested candidates may take the subscription plan that I provided the subscription link in the description box of this video, as well as my Unacademy profile link also I kept, because my profile link will be helpful to you to access the previous free classes whatever I took. So for that one you will get one idea that you are going to get 1 minute guys.
Unplug both of them, then plug the router back in.
Yeah. So based upon the previous special classes or the free classes, you will get one idea how the concept is delivering. Okay, and so here the different subscription plans are displaying on your screens. So 1 month, 3 months, or 6 months, or 12 months, okay, or 24 months. Okay, so you may take any one of the subscription plans here. That means when you want to write the exam, okay, based upon when you want to write the exam, so based upon that one you may take any one of the subscription plan. But if you are planning to take the subscription plan, then use my referral code, that is Ashwani, then you will get 10% discount on any one of the subscription plans. Okay. Fine. So now we will go into the few memory based questions guys. So one of the question I received is that the ZL, that is a load impedance whenever the short circuit, that means ZL of SC is equal to 150 ohms, and ZL of OC, that is the open circuited, is equal to 37.5 ohms. Okay, and in the exam they have to find out the Z0, that is the characteristic impedance. Okay, so for this one here directly you can take, that means Z0 square is equal to something expression we will get. So if you want to know that how you will get all these expressions, means first take the input characteristic input impedance of the transmission line, that is Z in can be taken as Z0 plus, sorry, Z0 into ZL plus Z0 J tan beta L, okay, for the lossless transmission line, divided by Z0 plus ZL J tan beta L. Okay, so in this case if they are asking for the ZL of SC is nothing but what you have to take is that ZL short circuited. Okay, ZL short circuiting means take ZL as a 0. So if I substitute ZL as a 0, then what I will get here is that this term will be vanished and this term will be vanished, and Z0 and Z0 both these two gets cancels. Then finally I will get the Zin is equal to Z0 J tan beta L. Okay, so it is for the short circuited one. And similarly, if I take for the ZL as a open circuited, that means you have to take ZL as infinity. Okay, why? Because open circuited means ZL becomes is equal to infinity, and ZL becomes is equal to infinity means take the same expression Zn is equal to, and take the ZL as a common from the numerator and the denominator. Okay, and if you take the common, then I will get as 1 plus Z0 by ZL J tan beta L divided by Z0 by ZL plus J tan beta L. And in this expression now substitute the ZL as a infinity. So after substituting, now this term becomes 0 and this term becomes is equal to 0. Now finally I will get Zn is equal to Z0 divided by J tan beta L. So it's nothing but minus J Z0 cot beta L. Okay, I will get like this. Okay, so these are the two expressions I got. Now if I multiply both these two expressions, okay, this one and this one, if I multiply both these two expressions for the load as a short circuited and the load as a open circuited, then I will get the Z0 square is equal to input impedance for the short circuited into input impedance for the open circuited. Okay, I will get like this. And for the short circuited, they given that 150 ohms, and for the open circuited they given that 337.5 ohms. Okay, so you have to calculate this one, and after calculating, then finally you will get the Z0 is equal to 75 ohms. Okay, so the Z0 is equal to 75 ohms is the correct option for this question. Okay, and next we will go to the next second question. Guys, if you remember any questions, then please mention in the comment section. Okay, that I will come up with the next video. Okay, the solutions for that one. And next, so coming to the square wave generator, I mean they given the example like which of the following is the square wave generator, and the options are just like option A. Option A is just like the free running multi-vibrator, nothing but a stable, and one shot multi-vibrator, and something like op amp feedback, op amp with some feedback, and option D is Smith trigger. Okay, so for this question the correct answer is a Smith trigger. Why? Because the Smith trigger can be called as a any to square waveform converter. Okay, it converts any signal into the square waveforms. Okay, so here the Smith trigger is the correct answer. So whatever the input you give, the output ultimately what we call fluctuates between the plus Vsat and the minus Vsat. Okay, so I mean if it is the upper triggering point is happening, then the output becomes is equal to plus Vsat, and whenever the lower triggering point is happening, then the output is, or else upper threshold point or lower threshold point, anything is fine, then output is equal to minus Vsat. Okay, so option D, I mean Smith trigger is the correct answer. Okay, and next, coming to the third question, they just given that list 1 and list 2 FM and DSB, SC and DP, SK and AM. So for this one, in the list 2, so FM goes to the ratio detector, because the ratio detector is one of the circuit which is used for the detection of the frequency modulated signal, and the ratio detector doesn't require any type of limiters. Okay, it is completely optional from the limiter, And coming to the remaining detector circuits, they definitely requires limiters. Why? Because whatever the peak of the amplitudes are there, they are affected by the noises. So that's why the remaining detectors require the limiters, but ratio detector is optional for that one. And coming to the DSPSC, the coherent detector is required. And coming to the DPSK, you can take the non-coherent detector. And coming to the amplitude modulation, you can take the envelope detector. Okay, so these are the related options to this given different types of modulation systems or else modulation techniques. Okay. Next, coming to the fourth one, it is also one type of list 1 and a list 2 question. So they're given just like the fastest ADC and the slowest ADC and most widely used and the resistor ADC. So the correct option for this one is the fastest ADC is the flash type. Okay, it is a very fast ADC. And coming to the slowest one is the counter type ADC. And mostly widely used is the dual slope. Okay, dual slope ADC. And why it is mostly used? Because even though it is slow, but it gives the most accurate readings. So the digital slope ADC is mostly used in the digital multimeter, especially due to its accurate measurements. And the next one, resistor, can be taken as a successive approximation type. Okay, SAR successive approximation resistor ADC. So these are the correct options for this one. And coming to the next question, fifth one. So order of the components they asked. Order of components in CRT. So generally they given few options, so I arrange them in the order, but I am writing here the order of the CRT component starting from cathode to the phosphorus screen. So based upon that one, you may check down. The first one is the cathode gun, and the next one is the control grid, and next one is the pre-accelerating anode. After the pre-accelerating anode, next one is the focusing anode, and next one is the post-accelerating anode, and after this one, next one is the vertical deflection system, and next one is the horizontal. So out of the vertical and horizontal, first vertical deflection will comes, and next the horizontal deflection system will comes, and next one is the aquadag material will comes, and next one is the phosphorus coated screen will come. The phosphorus coated screen can also be called as a raster. Okay, so it is the order, guys. So based upon this order, so I think in the exam they asked cathode gun, pre-accelerating anode, focusing anodes, vertical deflections, horizontal deflection, and the aqueduct. So I hope these are the points they're given. Okay, but anyhow it is the order, guys. Okay, and next, coming to the sixth one. So it is based upon the dual slope ADC. So based upon the dual slope ADC, one question is given to find out the time t2. So coming to the, whatever the data given is that the V reference is equal to 2 volts and output is equal to 10 volts and R is equal to 10 kilo ohms and C is equal to 0.1 microfarads. Okay, it is a data given. So they're asking the T2. So if you look about the starting stage of the dual slope, you will be having one integrator will be there. Okay, like this. So let's take it is a R and it is a C, and this integrator goes to one comparator, and then it goes to one AND gate. Okay, so like that it follows. And here the two input, one is the input voltage and second one is the reference voltage. Here one switch will be there, and the switch is continuously connected between the input voltage and the reference voltage. That is the speciality of the dual slope ADC. Okay, so now this voltage is 10 volts and it is 2 volts, and R1 is 10k and C is 0.1 microfarads. Okay, so usually what we call this integrator, okay, if it connects to the VI, okay, usually the output of the integrator we can take as V0 is equal to minus 1 by RC integration of VA into dt. Okay, we will take like this. And if the switch is connected to the input, then I will get the same expression. But if the switch is connected to the reference voltage, in the place of this VI we have to take the V reference. Anyhow, V reference is a constant, so you can take outside that one, and integration of dt you can take as a t. Let's take the T2. Okay, and whenever the input voltage is connected, then that becomes a T1, and whenever the reference voltage is connected, then we can take as a T2. So now from this expression, the T2 can be taken as V0 RC divided by V reference. No need to consider the negative sign. Why? Because the timings we will not get the negatives, right? And from this one, 10 into 10k into 0.1 micro divided by V reference is the 2. So 5, and finally I will get the 5 milliseconds. So here T2 because, so here the T2 is the 5 milliseconds. Okay, so it is the correct answer for this question. Okay, and next. So how many questions was done? 6, right? Next, 7th one. So a vestigial sideband is given, I mean VSB. Here one is complete sideband is there, and here the 25% is there. So usually one complete sideband power, let's take the USB. Okay, one complete sideband power can be taken as mu square AC square by 8. Okay, and so here it is the mu square A square by 8. And next here the LSB 25% is appeared. 25% means 1 by 4, right? So 1 by 4 means out of this one, 1 by 4 is appeared as a LSB. So 1 by 4 mu square AC square by 8. And combination of both these two power is given. Okay, that means the complete power for this VSB is given as a 0.625 watts. So just add both these two guys, and let's take the mu square AC square by 4 as a common. Then I will get mu square A square by 8 as a common. Then I will get 1 plus 1 by 4 is equal to 0.625. Okay, and from this one mu square AC square is equal to 0.625 into, if I do the LCM, then I will get 5 by 4, and if you take here 4 by 5 into 8, and in the question they given that the modulation index is a 60%, that means you can take mu as a 0.6, and now the AC square is equal to, just take this one here, so finally 0.625 into 4 into 8 divided by 5 into mu square, that is 0.6 whole square. Okay, so it is a AC square I will get, and after calculation you will get the 11.11, and they asked to calculate the carrier power of the amplitude modulation. The carrier power of the amplitude modulation is AC square divided by 2, that means 11.11 divided by 2, it becomes is equal to 5.55 watts. Okay, so it is a carrier power required for the amplitude modulation if the same signal is transmitted. Okay, is it clear, guys? So it is a one more question. Okay, so for more remaining questions that we will see in the next session, guys. So these are the questions that I want to discuss, and if you remember any questions, then please put your remembered questions in the comment section. Okay, and before ending up, then one more time that I want to tell you, I'm going to start the complete course for the fresh batch for the UGC NET Electronic Science as well as the paper 1 from November 9th onwards. So the interested candidates may take the subscription plan. The link and my profile link is also provided in the description box of this video. Okay guys, so by this I am ending my session. So if you want to ask me any questions, then you may ask, guys. So any questions? If you're having any questions, then you may ask. Okay guys, thank